For centuries, the moon has been a symbol of mystery and aspiration. But while pop culture and theorists debated what might be hiding on its shadowed surface, nations have been quietly racing to uncover its secrets. Recently, China made a discovery that bridges the gap between science fiction and reality, confirming that our celestial neighbor is far more dynamic and resource-rich than we ever imagined. This isn't just about rocks, it's about the future of humanity in space. Let's break down what they found and why it changes everything. Anomalous lunar structures. The notion of artificial structures on the moon has long been a fixture of speculative theories, often dismissed by mainstream science, but kept alive by intriguing images and anecdotal accounts. A key source of this speculation was the 1994 Clementine mission, a joint project between NASA and the US Department of Defense. Officially, its goal was to map the lunar surface and test advanced sensors. However, the 1.8 million images it sent back contained visual oddities that have fueled debate for decades. On the moon's far side, often mistakenly called the dark side, some of these declassified images appear to show geometric shapes and unnatural-looking formations that enthusiasts claim are evidence of broken structures or alien junk. One famous image features what looks strikingly like a pyramid, with sharp angles and a distinct shadow that seems out of place among the moon's natural craters. Theorists argue that many of these images show signs of deliberate obfuscation or blurring, suggesting an attempt to hide what was actually photographed. While scientists largely attribute these anomalies to digital compression artifacts and the play of light and shadow on a complex surface, for many, the Clementine mission was a reconnaissance effort to gather intel on something that was already known to be there. Ancient astronaut connections. The belief in lunar structures is deeply intertwined with the ancient astronaut theory, which proposes that extraterrestrial beings visited Earth in antiquity and influenced human civilization. Proponents of this theory point to various pieces of disputed evidence as proof of a continued alien presence in our solar system. One of the most cited examples is an alleged black box audio recording from the Apollo 11 mission. In this supposed transcript, Neil Armstrong is claimed to have said, "Look at those convex structures down there," describing them in a way that implies they were dome-like and artificial. While the authenticity of this quote is widely rejected and considered UFO folklore, it taps into a powerful narrative of cosmic secrecy. This narrative is further bolstered by interpretations of ancient texts, like the Sumerian tablets, which describe beings called the Anunnaki. In these stories, a god figure takes his son to the moon and tells him to wear his eagle's mask, which theorists interpret as a breathing helmet. The idea is that these ancient gods were actually extraterrestrials with advanced technology, and their masks were the helmets needed to survive in harsh environments like the moon or Mars. This connects to countless pieces of ancient art, such as the Wandjina cave paintings in Australia, which depict figures that look uncannily like modern-day astronauts in bubble helmets. China's groundbreaking discovery. While theories about ancient aliens capture the imagination, China's lunar program has delivered concrete, game-changing discoveries grounded in hard science. The nation's crowning achievement was the Chang'e 5 mission, which in December 2020 successfully landed in the Oceanus Procellarum region, drilled into the lunar surface, and returned with 1,731 grams of fresh lunar soil and rock samples. This was the first time any nation had retrieved lunar material in over 44 years. After months of intensive study by Chinese scientists, a landmark announcement was made in 2022, the discovery of an entirely new lunar mineral, named Chang'e Y. This tiny, transparent columnar crystal was a monumental find, making China the third country in history, after the United States and the former Soviet Union, to discover a new mineral on the moon. But the revelations didn't stop there. Analysis of the soil samples also confirmed the presence of water, but in a completely unexpected form. Scientists found water molecules locked within tiny, soil-embedded glass beads, which were formed during the violent high-heat events of asteroid impacts. This discovery was revolutionary, proving that water on the moon was not just confined to ice at the poles, but was more widely distributed across its surface. Revolutionary implications. The confirmation of water within lunar soil has staggering implications for the future of space exploration. It is honestly the key that unlocks the concept of in situ resource utilization, or ISRU, which means the ability to live off the land. For decades, The logistics of a permanent human presence on the moon were, well, deemed nearly impossible due to the prohibitive cost of launching every necessary resource, water, air, fuel, from Earth. China's discovery changes this equation entirely. The water trapped in these glass beads, while minuscule in each particle, could amount to as much as 270 billion metric tons across the entire moon. With the right technology, rovers could heat the lunar soil to release this water vapor, which could then be collected and stored. This water could be used for drinking and agriculture in a future lunar base. More importantly, through a process called electrolysis, it can be split into its component elements, hydrogen and oxygen. This provides a source of breathable air for astronauts and, critically, the two primary components of modern rocket fuel. The moon could effectively become a celestial gas station, where spacecraft launching from Earth can refuel for missions to Mars and beyond. This dramatically reduces the mass and cost of deep space missions, making the sustained exploration of our solar system a far more achievable reality. The Chang'e program evolution. China's triumph with Chang'e 5 was not an overnight success, but the result of a meticulously planned multi-decade endeavor known as the Chinese Lunar Exploration Program. The program, named after the Chinese moon goddess Chang'e, unfolded in a series of logical, increasingly complex steps. It began with Chang'e 1, launched in 2007, and Chang'e 2, launched in 2010. These were two orbital missions that mapped the lunar surface in high resolution and scouted for future landing sites. The next phase involved landing on the moon. In 2013, the Chang'e 3 mission successfully touched down, deploying the U-2 rover and making China the third country to perform a lunar soft landing. Then, in a stunning display of technical prowess, the Chang'e 4 mission in 2019 achieved what no other space agency had ever attempted, a successful landing on the moon's far side. This historic feat required a dedicated relay satellite to maintain communication with Earth. The program's third phase culminated with Chang'e 5 in 2020. This mission showcased China's mastery of incredibly complex maneuvers, including an automated launch from the lunar surface and a robotic rendezvous, and docking in lunar orbit to transfer the samples for their return journey. This steady, step-by-step evolution has, firmly established China as a top-tier space power. Resource revolution on the moon. The Chang'e 5 samples have kickstarted a complete re-evaluation of the moon's economic and strategic value, transforming it from a barren wasteland into a treasure trove of vital resources. The discovery of Change Site Y was significant not just because it was a new mineral, but because it is a phosphate mineral that contains helium-3. On Earth, helium-3 is incredibly rare, but it is abundant on the moon, having been deposited on the lunar surface by solar winds over billions of years. Scientists believe helium-3 is the perfect fuel for nuclear fusion, the same process that powers the sun. A fusion reactor running on helium-3 could provide a safe, clean, and virtually limitless source of energy, without the long-lived radioactive waste produced by current nuclear fission reactors. The ability to mine helium-3 could revolutionize energy production both on the moon and back on Earth. Beyond helium-3 and water, the lunar regolith is also rich in rare Earth elements, like neodymium, lanthanum, and yttrium, which are essential components in everything from smartphones and electric vehicles to advanced military technology. The moon therefore represents a potential solution to Earth's dwindling resources and could become the cornerstone of an interplanetary supply chain. Future lunar colonization. With confirmed access to water for life support, hydrogen and oxygen for rocket fuel, and helium-3 for energy, the dream of establishing a permanent human colony on the moon has officially moved from the realm of science fiction into the strategic plans of spacefaring nations. The ability to use local resources is, honestly, the key to sustainability. In March 2021, China and Russia capitalized on this new potential by signing a memorandum of understanding to jointly construct the International Lunar Research Station. This ambitious project envisions a permanent, autonomously operated base located at the moon's south pole, a region believed to hold large deposits of water ice in its shadowed craters. The ILRS is planned to be operational by the mid-2030s and will be a complex for scientific research, resource extraction, and technology verification. It will serve as a testing ground for the technologies needed to support human life in deep space, and act as a crucial staging point for future crewed missions to Mars. China has even floated the idea of building a nuclear power plant on the moon by 2028 to provide the substantial energy required for the base's long-term operations, demonstrating a clear and determined vision for lunar colonization. Lunar resources, the new gold rush. The scientific confirmation of vast and valuable resources on the moon has, ignited a 21st century gold rush, sparking some pretty intense geopolitical competition for control over lunar territory and its riches. The economic implications here are just enormous. The ability to mine water, helium-3 and rare earth elements could, honestly, create entirely new industries and shift the global balance of power. This has turned the moon's south pole into probably the most desirable real estate in the entire solar system, as its permanently shadowed craters are thought to contain massive, accessible deposits of water ice. However, this frantic race to the moon is unfolding in, a legal gray area. The 1967 Outer Space Treaty, which is basically the foundational document of space law, clearly states that no nation can claim sovereignty over any part of a celestial body, but the treaty is, pretty silent and ambiguous on the issue of resource extraction by commercial or state entities. It does not explicitly prohibit mining, nor does it establish a clear framework for who owns the resources that are extracted. This legal vacuum is creating a high-stakes environment where nations are rushing to establish a presence, a sort of facts-on-the-ground precedent, to bolster future claims to lunar resources. International space race. The modern space race is, a multipolar and multifaceted competition, and it's really starkly different from the old two-nation Cold War rivalry. In one corner stands the United States, which is pursuing a return to the moon through NASA's Artemis program. The program's stated goals are to land the first woman and first person of color on the lunar surface, and to establish a sustainable, long-term human presence. A key feature of the Artemis program is its deep reliance on commercial partnerships. Instead of building all its own hardware, NASA has contracted private companies like SpaceX to develop the Starship human landing system and Blue Origin to build a second lander. This public-private model aims to foster innovation and reduce costs by leveraging the dynamism of the commercial space industry. This approach is actually codified in the Artemis Accords, a set of non-binding principles for safe and transparent lunar exploration. The accords have been signed by dozens of countries, creating a pretty broad US-led coalition. This collaborative yet commercially driven strategy represents a fundamentally different philosophy from the state-controlled programs of its main rivals, and it's really setting the stage for a new era of exploration, defined by competing models of international cooperation. Competition between China, US, and other nations. The new race to the moon is honestly increasingly defined by two major competing blocks. On one side is the US-led Artemis Accords, which brings together established space powers like Japan, Canada, and the European Space Agency, along with emerging space nations, under a common framework for lunar governance. On the other side is the China-Russia Alliance for the International Lunar Research Station. While this partnership is currently smaller, it is actively recruiting other nations, with countries like Pakistan, the UAE, and Venezuela having signed on. This creates a clear geopolitical divide, extending terrestrial rivalries right into the celestial sphere. However, it's not strictly a bipolar race. Other independent players are making significant strides. India's space agency, ISRO, achieved a major triumph in 2023 with its Chandrayaan-3 mission, which successfully landed a rover near the lunar South Pole, a historic first. This really demonstrated India's growing capabilities and its intent to be a key player in lunar exploration. The landscape is a complex tapestry of national ambition, commercial interests, and strategic alliances, where intense competition is the primary driver of innovation, but the immense challenges of space may ultimately necessitate cooperation between these rival factions for humanity to truly establish a permanent foothold on the moon and beyond. From mysterious anomalies to game-changing mineral discoveries, the moon has once again captured the world's imagination. It's no longer just a silent, barren world, but a frontier of immense scientific and strategic importance. China's recent findings have accelerated a new era of exploration, pushing humanity to answer some pretty profound questions about our past and our future in the cosmos. So, what do you think is hiding on the moon? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of science and technology. Thanks for watching Future Facts.